Good morning, everybody. My name is Kate Burlington, and I'm going to talk to you guys about nonlinear content sequencing in e-learning, which is a really interesting and exciting topic in the realm of instructional design. So let's take a look. The first question you might fairly ask is, what is it? You probably know what content sequencing is, which is simply the question of what order you should put instructional activities in. And this is a very old topic in instructional design. Linear versus non-linear content sequencing is a relatively more recent topic of research, and a lot of that arises from the possibilities inherent in e-learning environments. So linear content sequencing is essentially what it sounds like. And it's the traditional form that content sequencing has typically taken. You put all of the activities in order, and one follows after the other. And in traditional learning environments, the face-to-face classroom, this is more or less what you have to do. If the instructor is presenting the material and leading the learning activities, they have to take on a linear format following one another. Non-linear content sequencing can follow many different models. One of them is the common introduction, which you see illustrated here, where all of the learners in your class take part in a common introductory activity, and then they're provided multiple pathways that they can follow according to their own choice and their own interests. These can be parallel pathways, or you can allow them to simply choose the order in which they take on these subtopics. There are numerous advantages to nonlinear sequencing, so let's take a look at a few of those. The first one is that nonlinear sequencing helps address one of the ongoing, sort of eternal struggles in instructional design, which is how do you deal with disparate learner levels? Learners come into the class at all levels of readiness and background knowledge. And nonlinear sequencing has the potential to allow learners who need extra time or extra materials to access those, while allowing learners who are more advanced to move ahead into more complex activities. It's also consistent with universal design for learning principles. By allowing learners to choose their own pathway, you're allowing them multiple means of engagement, which is a core part of UDL. There have been numerous studies showing that learner control is also beneficial to learning outcomes. Most of these studies have been in the realm of e-learning training rather than in academic settings, but there are several high-quality qualitative and quantitative studies which show that learners benefit from being able to control the order and timing in which they learn. So if nonlinear sequencing is so great, why hasn't it totally taken over and become the standard? Well, there are several disadvantages that we should talk about. The first one that comes to mind is that there have been studies showing that nonlinear sequencing is potentially harmful to less motivated students. There's been a study showing that highly motivated, intrinsically motivated students do better when given the opportunity to choose their own learning path, but students with less intrinsic motivation tend to flounder. There's also the elephant in the room of the time investment that it takes to develop nonlinear courses. Because you're designing more complex learning paths and potentially giving learners more options, it just takes much more time and resources on the part of the instructional designer and the instructor in order to conduct these courses. So, should we use nonlinear sequencing? Sometimes. It certainly can be beneficial depending on the topic, if the topic lends itself to multiple pathways, and if you have the time to invest in designing a nonlinear course, then there's definitely research to back up the idea that it can be highly beneficial. If you want to find out more, check out the links in the video description below.